What is a blockchain? Animated examples. In this video, we are going to explain what a blockchain is in very basic terms. By the end of the video, you'll be able to explain this life-changing technology to those you love, saving them from the authoritative dictatorships that never cease to control your every move. Welcome to Crypto Codebreaker, your gateway to unraveling the mysteries of cryptocurrency. Don't forget to show your support by liking the video and hitting that subscribe button. Here, we explain topics of the cryptocurrency world using analogies, stories, and examples so that you can easily understand them. For the numero uno crypto, Bitcoin, this data is literally just a list of transactions. For example, it might look like this. X pays Y $50, A pays B $80, and Y pays H $15. If we're dealing with Ethereum, it's usually just transactions, but it can be a few other things like things called smart contracts, which are really neat. But we'll have time to explain them in another video. For some altcoins, it could be your internet use or your files or papers. Regardless, a block is just a group of records. To show you what a blockchain is, I'll use a record of events. Like in Bitcoin, this record is called a ledger because it shows payments for goods and services. Blocks do have limits, and they can only hold a certain number of transactions. That means we have to keep adding blocks. Using Bitcoin as an example, there are currently about 1,500 transactions in a block on average. You don't need to know why this number changes. Please be aware that these blocks will fill up and we will need to do something with them. Well, what do we do when these blocks are full? We add them to the network. Now, you might be asking, how do we do that? Well, we do something called mine them. And since Bitcoin is a proof-of-work model, we have to prove that we mined them. This brings us to something called a hash. So the next big question is, what is a hashing function? A hashing function is a system where you can put something into it, and it'll output a hash. There's a ton of math happening inside this magical black box, but essentially, you give it something, and it gives you something. In this case, Bitcoin uses the SHA-256 hashing function. SHA stands for Secure Hashing Algorithm, and 256 refers to the amount of zeros and ones that it has in whatever it puts out. That is, it will always give you 256 zeros and ones, whether you type in your name or the whole dictionary. Because computers are smart, they changed these 0 seconds and 1 second into letters and numbers, and the process is hard to understand. It could be a whole video. However, there are three main things you need to know about hash functions. For starters, you can't find a hash's data. You have to guess and check. That is, if you give it A, it will return a D. After that, if you give it AA, it will give you J. After that, if you type AAA, it will return U. If you wanted to know what got you a F, you'd have to keep adding as until you tracked it down. What you need to know about hash functions result changes a lot when you change the input just a little. In short, if you SHA-256 this and subscribe to our channel, you'll get this back. You get this if you do. Please subscribe to our channel. No changes were made to these, even though we added one word. And lastly, the third thing you need to know is that calculating the hash takes some time. Now, it might only take a few milliseconds for one tiny string of text, but if you have an entire book that you're doing, or if you want to check a few million variations of it, it starts to rack up time and computing power. And so, what Bitcoin is doing, whenever you mine it, is we're trying to add random numbers to whatever the block is, so that we get a special ending. For example, let's say we're trying to mine this. X pays Y $50, A pays B $50, and Y pays H 15. You'll get this as the output. Now, Bitcoin does this. It asks itself, what number do we need to add to the end of that list to get a 0 at the end of the hash? Using my little Python program, we can check it with 0, 1, and 2, and then with 2. This shows that it takes 3 checks before you get to the first one, which is when you add a 2 to the end of it. Let's make things a little harder now. Try adding 2 zeros to the end of the number. We found out that it takes 438 tries to get to the first hash that ends with 0, 0. Here's one last thing to show how much longer it takes to find these hashes. Let's see how many times we have to guess before we get 5 zeros. We get a very large number when we run the app. So, as we look for more zeros, it takes a lot more time to check it. And essentially, Bitcoin is looking for a lot of zeros, and computers all around the world and mining farms are mining away to find the right number. When they do, we say that that block is solved and verified. But we'll get into that in a little bit. The second thing you should know about a blockchain is that it is not controlled by one person or group. It doesn't have to be really hard to understand this. Take a look at it this way. If something is centralized, it means that one person runs it. One example is that only your high school teacher could add to or change your grades. You could fail if they didn't like you. Maybe you didn't understand what they were teaching because they were bad at it. This isn't meant to be annoying. Decentralized basically means that more than one person can see and change your grades. Let's say that all of your classmates could see the test results and give you a grade based on your papers and tests. It would be cool if more than just your teacher could decide what grade you got. So, this is what decentralized really means. All Bitcoin transactions are not kept by just one person. Anyone who wants to can have them and look at them. And not only that, because this is the important part, anyone can mine and actually vote on the blockchain. This means they can say, Bill really did pay John 50, or they could make fake transactions and say, John paid Bill all of his money. So you might be asking, how do you make sure that someone doesn't make a fake transaction and spend all of my money? Well, that's a problem that is solved by using asymmetric encryption with cryptocurrency wallets. It's a little confusing, and we just finished a few videos on it, so you should go check those out after this video. But bringing us back to what decentralized means, that begs the question, why would a group of teenagers want to look at your papers and tests? Even more so, why would they want to spend a lot of time looking at them and then grade the tests? Well, they would be paid to in this case. In almost all blockchains, voting well earns you a prize. Say you get paid in Bitcoin for mining Bitcoin. I really hope that comparison makes sense. A block is just a bunch of info, which is what we've talked about so far. What a hashing function does is make sure that people who want to be a part of the blockchain actually do work. Decentralized means that it is not run by just one person, which is what we talked about. So, if you're still with us after me explaining these interesting topics, please consider clicking that like button. It gives us fuzzy feelings inside and promotes our hard work. Next up, let's learn why it's actually called a blockchain. With Bitcoin, there are two extra things you need to know about. 1. Whoever solves the block and finds the magical hash that has however many numbers of zeros we're looking for, they add "Y Board Crypto's account received 2 Bitcoins for mining" at the top of the block. And this is their mining reward. This is how more Bitcoins are actually created, although that number 2 changes, and it gets smaller and smaller as time goes on. Second, you should know that the hash of the last block is added to it. That is, the last block's password is added to this one, and that hash is used to figure out this block's hash. Since each block points to the previous one, we can call it a chain. Here's where the blockchain's magic happens. You messed up the hash that the old block pointed to, so when you try to edit it, all the new blocks change. Remember when we talked about SHA-256 and the hash function? It changes everything if you make one small change. So now we know someone won't go back and add more money to an old block. In a sense, whatever gets added to the blockchain is written down in history forever because it can't be changed. Now, this is actually really good for things like transactions, but it's bad for things like copyrighted material or embarrassing things. 'Tis the nature of the internet though. So in conclusion, we have blocks that consist of data, and in the case of cryptocurrency, it's usually a list of transactions. Next, after we have a block, we have to find the password to that block, or basically, what is the hash that solves that block? And miners do this by guessing and checking until they hit the jackpot. After figuring out how to solve that block, they make sure it's connected to the last block, because it points to a block before it. Each block has the background of every transaction on it. Now, each block is linked to the previous block, making a chain. A blockchain is that. I hope this topic is a little easier for you to understand now. Welcome to Crypto Codebreak, your gateway to unraveling the mysteries of cryptocurrency. Don't forget to show your support by liking the video and hitting that subscribe button. Here, we explain topics of the cryptocurrency world using analogies, stories, and examples so that you can easily understand them. We hope to see you in the next video.